Hey everybody, I'm Marcus, Developer Relations at Edge and Node. Welcome to another episode of the Graph Builder's Office Hours. Today we're going to be going over querying the graph network and really understanding the graph network as a whole, how to interact with the graph network, how to start building your dApp with all of the subgraphs that are available. But before we get into that, I want to get through a few announcements. There are a few things that I would like to share. Between now and June 12th, we have an upgrade window that's going on right now. Let's go ahead and talk about Sunbeam. Sunbeam has begun. So if you have the ability to upgrade any of your hosted subgraphs before June 12th, that is something that you should do. And then also getting the information out there to the world about Sunbeam, the upgrade window is here. It's now something that the graph ecosystem has been pushing towards for 6 years is actually here. It's very exciting. So please check out this blog post. I will drop this in chat. And then after you have upgraded to the graph network and started to interact with your subgraph on the decentralized network of indexers, some other pieces of reading material that you should check out is, of course, optimizing your subgraph. You want to really make sure that you're optimizing your subgraph to the best of its capacity. And here are 3 fantastic blog entries that you should go through just so your subgraph can maintain its peak performance. So this is 2 simple subgraph performance improvements by David Luttercourt. And then also improve subgraph indexing performance easily, reducing ETH calls. And finally, Kevin Jones, who's in chat, who's in here today, best practices in subgraph development, avoiding large arrays. He wrote this one. And I forgot to mention, of course, Simone wrote this one about reducing ETH calls, Simone Emmanuel Schmid. So please look at these different blog posts after you have upgraded your subgraph, or even before you've upgraded your subgraph. All 3 of those are going to be helpful in your subgraph development experience. So let's get into first understanding really quickly the graph network for those of you who are somewhat new to the graph out there. Let's just say, hey, the graph network is decentralized indexing. If you want to learn more about that, about decentralized indexing, what that is, go into the docs. There's some good information on there. I'm not going to spend too much time on this because I really just want to get into querying and building with subgraphs on the graph network. So feel free, of course, to reach out to me if you have any questions about the graph network as well. If you would like, there's a repo in this workshop. I'll also drop this into chat as well. This will really help your building journey. There's drag and drop pieces of code in here for vanilla JavaScript, Python, Apollo, and Graph Client, where all you got to do is drop in your API key into these different little files, and then from there you'll be able to query the graph network. You just have to drop in your API key, and of course the appropriate query, and of course the appropriate endpoint, and then from there you'll be able to build much faster. So this repo is just for you. Before we really get into the presentation too deep, what I want to do is just copy paste all of these links into the chat right now while we're here. This is Sunbeam, and if there's any questions, yeah, feel free to. Yes, I'm once again asking to optimize the subgraph. Feel free to share this information around. We've got the Sunbeam upgrade window in there. And then also these are the optimization techniques that are really quite important that I think should be standard reading for intermediate subgraph developers who are looking to just improve from the beginner level of subgraph development. There we go. Tab switching, tab switching. And then finally, of course, I wanted to share subgraph query workshop. That's it. And this is the repo for today's workshop. Okay, so let's keep on going with this presentation. It is not the answer that enlightens, but the question. I think curiosity is the best emotion of all emotions. Now, there's a lot of emotions out there, but curiosity, in terms of taking action, in terms of internal incentivization, being curious will always lead you to more action. It will always lead you to finding the next thing around the corner. It will always lead you to digging deeper. And I think as we interact with a lot of data, behind that is a lot of curiosity. Can we be curious about something in our minds and say, hey, maybe this is something we can dive into. Let's dive into it using the graph and subgraphs. So let's think about that as we move forward here. What are we curious about in Web3, and what questions could we ask? Well, the good news is we can use subgraphs. And specifically, really quickly, as a quick overview of what subgraphs are customizable APIs that we could all build, and subgraphs are valuable. Okay, those are the two things we need to remember. And essentially, we have a footage of subgraphs in action. This is a good little GIF for that. It simply organizes our data for us. And then from there, they are customizable instructions that we are able to build. We're not going to really get into this building too much. We're just going to understand this schema.graphql file in this presentation, because if we're going to query the graph network, we're going to need to know how the database is organized. And so that's the only file we're really going to look at. And then these subgraphs, as they're on the graph network, they're all on the Graph Explorer, of which is going to be the jumping off point to really go into all of these decentralized endpoints and how important those are for the health of Web3 as a whole. So that's just a really quick overview of what subgraphs are. And I did say they are published to the Graph Explorer. Any subgraph in the Graph Explorer is on the decentralized network of indexers around the world. So that's really cool. It is open data. And being able to access this open data is something that we can all do, all of these nice buckets of organized data for us. So are there any questions before we get into steps to query a subgraph? Let's get into this. So steps to querying a subgraph. Really, these are the 4 steps that are needed to query a subgraph that's on the graph network. First things first, we're going to set up an API key, and we're going to go over a few things about the API key, specifically API key security, making sure that API key is secure. Then we'll also after that, we'll go find and assess a subgraph on the Graph Explorer, which is on the graph network. We'll see what that subgraph is like. We'll see the data inside and see how that subgraph is organized from the database. And then also we will design some queries in the subgraph's playground and design those queries to send to that subgraph's endpoint and then get that response back. We'll play around with that a little bit. And then, as I opened with in this presentation, I show you that repo where we could integrate the query with the dApp. I'll also bring that back up, and we can briefly go through that repo and show how to integrate queries that we've built with a dApp. So first things first, let's go ahead and set up an API key. All right, so we'll just go to thegraph.com. And this is the first thing that we need to do anytime we are interacting with the graph network. We need to have an API key to send some queries should we want to be able to do this. So we'll go to Subgraph Studio and we'll go to API keys. And from here, we will go to create an API key. And we'll call this GBOH demo, Graph Builders Office Hours. And here we have our API key. Done. Very simple. It is in here. We can copy paste it and drag this into our decentralized application when we're ready. But one thing I want to highlight is security. This is very cool in that our API key has access to our GRT work utility token. The subgraph that the API key is being used with can be restricted. Oh, let's back that up. The API key can be restricted to the subgraph, a specific subgraph of our choice. So if we want to restrict that API key to a subgraph, we just select the subgraph that we would like to restrict it to. And then from there, if that API key for whatever reason is taken and trying to be used with other subgraphs, it can't be. And then also we can restrict the API key to a specific domain. So any domain that we would like, we can say, hey, if we have, for some reason, this API key gets stolen and taken somewhere, it can only be sent through this domain. And that is also another nice security feature. 2 things that are quite nice to have. So those are the 2 main features for that API key security to go over. Now let's go ahead and see how do we use this API key. So step 2 is to go find and assess a subgraph on the Graph Explorer, on the graph network. So we're going to do that right now. And I want to go over a few steps on this assessment of a subgraph on the graph network. So there's 4 things I really look at every single time I go through a subgraph on the Graph Explorer. That's the decentralized subgraphs out there. I look to see, is it a Messari standard subgraph? If it is a Messari standard subgraph, Messari is a core development team working on building the graph. The Messari standard subgraph, the Messari team is responsible. They are a data analytics company. They're responsible for building hundreds of high quality subgraphs and therefore hundreds of publicly accessible data that we could all access. So if we ever see Messari tag on the Graph Explorer, we know it's being built by a professional team responsible for having standardized databases. For the most part, they're almost all standardized as long as they're in the same category, and we'll go over that too. Just know, you see the Messari tag, it's going to be a solid subgraph, okay? The next thing we want to take a look at is the curation level, which essentially is the incentivization on that subgraph to be indexed by indexers around the world. So the more quality that subgraph is, the more likely the higher curation level is. Now, it's not necessarily like saying something with low curation is a poor subgraph. It's just more likely. If there's more GRT work utility token on that subgraph, it's going to be more, there's going to be more incentivization and more utility in the marketplace for that subgraph. So that's just helpful to know and just something to keep in the back of your mind. So after we get through those two, the next two things I look at are a little bit more specific to the subgraph. I like to go into the repo of the subgraph and actually look at the repo's code to see if the documentation is good. And that just gives us a good kind of idea if the subgraph developer, number one, has allowed us to look at their subgraph, because sometimes subgraph developers will publish their subgraph to the graph network and not apply the link to their subgraph's code. That's okay. They don't have to do that. But if they do, that's very kind to us. We could actually have that subgraph accessible, see what they're doing with the data, and then also see if there's documentation. That's also very helpful. And then the last thing, and a very important thing, is the schema.graphql comments. If there are comments in the schema.graphql, that means the subgraph developer has taken the time to think through pretty much the open source, the open nature of the data, and been kind to people who are using their subgraph and saying, hey, if you query this field on this entity, this is the specific comment in that will provide you more context to exactly what you're querying. So I'll get into all of these and we'll understand each of these a little bit better. Let's start with the Messari standard subgraph. So if we look at the Subgraph Explorer here, this can be found by just going up here, going to the Graph Explorer. We can see there are 1796 subgraphs by names and owners of subgraph ID, which is very cool. We could also search by the name of the subgraph, and then also we could search by the QM hash of the subgraph, be it the subgraph ID or the deployment ID. That's a new feature that just came out, pretty dang cool. And then also, if we want to go ahead and take a look at this right here, these are subgraphs being incentivized by the GRT work utility token on Ethereum. And these are the subgraphs being incentivized by the GRT work utility token on Arbitrum. If you don't want to dive into that, that's fine. But basically, we have almost 1,800 subgraphs on Arbitrum, on the Arbitrum token, and over 1,000 also on Ethereum, which is very, very cool. So as we see here, there's a few Messari standard subgraphs. So we see there's an ENS governance one, a Uniswap, V3 Arbitrum. And if we want to see all Messari subgraphs all at once, that's going to be something we could do too by simply going to subgraphs.xyz. This is Messari's dashboard that they maintain that allows us to understand, okay, we can go search the Graph Explorer and find all the subgraphs on the graph networks. That's great. But how do we know which categories are, which subgraph is in which category? And that's where this website is in a lot of use. So these are all bridge subgraphs. All of these different subgraphs will have the same schema. And that might be like, well, why is that useful? By having the same schema or nearly the same schema, sometimes there's slight differences here and there, but for the most part, what we can do is send a single query to multiple subgraphs all at the same time. And that is incredibly powerful. So if we want to understand, let's say, all these exchanges, and we design one query that says, hey, let's look into Balancer, let's look into Curve, let's look into HoneySwap, let's look into PancakeSwap, all of these all at once, we can do that and send one query to all of these subgraphs all at once, as long as they are under this exchanges category. And that will bring back that information, and we can see what's going on in Web3 very quickly and get that analytics data back, and from there create some value on saying, hey, this community and this community and this community are all doing unique things. This is the information back. That's super duper powerful in terms of using these subgraphs. So already we have a use case. We have a use case of saying, which exchange do we want to take a look at? Uniswap? Do we want to look at, let's say, the 721 being able to send these to the generic subgraphs? Go through subgraphs.xyz and think, okay, if they're standardized schemas, how could I send one query and learn about all these different governance communities in Web3, all these different lending ideas? There's so many different use cases. If we can think, how could we send some questions across all of Web3 and get that information back? Messari subgraphs are the way to go. We'll go into that a little bit more in the future. So next thing, after taking a look at the Messari subgraphs, I like to take a look at the curation level. And so we see right here, this is organized by curation signal. Remember I said the more actual signal being placed, or the more GRT work utility token being placed onto that subgraph, there's more incentivization to have more indexers hop in and index that subgraph. And there's a few other things that go in with the tokenomics of that, but just for now, just know that, hey, we've got a few different subgraphs here with a good amount of GRT on them. So we can see this one, this Aave V2, if I click on it, we'll see we've got 6 indexers on this one right here. It is fully indexed, and we can see a little bit information about this subgraph itself. And we'll go into this a little bit more specifically into a single subgraph, but as a high level, we understand with a little bit more GRT, it's likely going to be a more valuable subgraph. Now, that's not always the case, but for the most part, that's what we see in the marketplace. Now, the next thing that we go into, we got to dive in a little bit deeper, and we go into the actual code comments, and we actually go into the schema.graphql, the actual file itself. So to do this, what I like to do is go to the subgraph that I first got introduced to years ago with the Graph Network, which is actually the CryptoPunks subgraph. And it's funny enough, I didn't know this at the time, but one of now my coworkers was one of the designers of this subgraph. Jerry Okolo designed this subgraph, and I got to know him through his code here. And that's the cool thing about the Graph Network. It is a community of people who are all working together to provide this open data. Once you publish a subgraph on the Graph Network, it's pretty cool. We get to build with each other. So we can see already there's a Masari standard subgraph that is potentially quite valuable. Make my screen a little bigger for the presentation. We already know that's valuable. Here, we've got 2K GRT on this subgraph. So that's also got some value. So just to show you, there might be a certain way that data is organized with this Masari subgraph, and there's going to be a certain way that Jerry also organizes his subgraph. So let's go into Jerry's. Let's take a look at it and see, just for us, okay, what are his comments? What did he put in here? Well, he put a little bit of explanation here, a little high-level overview. We got a good amount of indexers on this subgraph, and then here we've got the Jerry Okolo repo. And let's see what his comments are. We can see, very nice. This subgraph developer, Jerry, has put in some information for us to have a high-level understanding of that subgraph. That's very kind for us because we're about to query the subgraph. If we're going to send queries in the playground, we should absolutely, number one, read this README. But number two, I think something that's very important is go to the schema.graphql. And from here, this is what I was talking about with comments. If we are ever sending a query to an entity, this is the account entity right here, and we send it to the account or the accounts entity, and we send it to the field of ID, well, an ID could be a lot of things. Jerry decided to use the Ethereum address as the ID. And just because he put the comment in there, we know when we send a query, we don't have to go and actually dive deeper into the code and see, well, what is actually populating this ID? And all of these comments are very kind of Jerry to put this into the subgraph. And then from there, anytime we send a query out there, we can be confident about the actual return on this data. And of course, if we want to audit this, go deeper into the subgraph, we can. But right now, we're just going to take this comment and say, all right, well, that's what we're getting. All right. So that's really how I go through any subgraph, where we go through the Masari. If it's a Masari subgraph, I still, of course, go through curation, documentation, and the schema. Even if it's a Masari subgraph, I like to dive into the comments there. But this is generally what I do. So go through it and assess a network subgraph to say, hey, is this valuable to me in my use? From there, we can actually go ahead and start sending some queries. So this is the playground right here, and we're going to go into this playground a little bit. There's filtering in this playground, which is a cool feature. Logical operators, we can actually save the queries, and there's many other query features that are available in this playground. But really, we're going to start designing these queries to answer some curiosity, some of our questions, and we're going to do that with these example queries. I'm wondering, let's say, what are the first 10 sales in CryptoPunks history? And maybe I'm also wondering the first 100 sales between these two timestamps of January 1st, 2019, and this is February 1st, so in that month. And then what is the total value of sales, total supply, and the total number of sales on the CryptoPunks contracts? So these are some interesting questions that we could ask of CryptoPunks. Let's go into Jerry's subgraph and figure that out. So here is our playground, okay? So if we want to ever send queries out, we're able to send this demo query out, very nice. we're able to go to this little folder right here and say, all right, these are all of the entities that are in this subgraph. And from here, we can say, awesome, let's go ahead and send a query out. So we know we wanted to look at sales, the first 10 sales. If we ever wanted to look at a singular sale, we'd look at the singular version of that entity. There's always a singular and a plural, and we could actually populate that with the specific ID of that sale. But we don't want one sale. We want the first 10 sales, okay? We're going to always want the ID. I always like the ID whenever I query an entity, just to understand what we're getting. And then also we're going to know the timestamp. When was it first sent? And we're going to need to organize our query, because if we just send the first 10 by ID timestamp, it's not necessarily organized. You can kind of see how this is just a smattering of data coming through. We need to order it by the timestamp. This is a little bit of filtering. And we'll have the order direction be ascending. So we'll start from the low and then go to the high. So here we have the first 10 sales of all time right there, which is pretty cool. If we would like, we could take this query and send it directly to this endpoint. Remember I talked to you about that API key that we started with? All we would need to do is in our decentralized application that we're building, drop in our API key right there, and we are ready to query the Graph network. Every month, you get 100,000 free queries on the Graph network, which is a big deal, to say, hey, this subgraph is on the Graph network. I've designed a query right here. I'm ready to send it to the endpoint. Go ahead and drag and drop that copy the query URL with the API key and continue building. We'll do that a little bit more in a second. But essentially, that's the workflow where we can design some queries, see if the data we're getting back is what we want, go ahead and drag and drop our API key into that endpoint, and from there, go ahead and build. So very cool. Let's keep on going to the next question. The first 100 sales between timestamp here and timestamp here. This is a little bit more in terms of what we could do with GraphQL queries. And so let's go ahead and do that. Just go through that feature. Let's go to the Subgraph Explorer and say, all right, well, we want the first 100. And we also, let's see if we can get the amount. Why not? Let's see what the amount was. And we also want to do a little bit of filtering. So we will do where the timestamp is greater than, I see GT, that's greater than. Timestamp is greater than. Here, we'll drop that in. And we also want to say the timestamp is less than this, because we have January and February of 2019. Okay. So timestamp less than. Very nice. So a little bit more of an advanced query. And now we're filtering. We're having more accurate filtering. And we could do more filtering, greater than, less than, not, less than or equal to. Lots of different things that we could do with this. Now, if we ever like any of our queries, we could see what queries we made in the past. We could star them and say, hey, that's a good query, that's a good query. There's a lot of cool features in here. But for right now, that's really the two that I want to take a look at. The last one, what I'll do here is just show you how a subgraph itself, many times in a subgraph, they are performing compute. And if you see any entities with comments, any fields with comments that have what seems like compute, what are the total value of all sales, total supply, and the total number of sales in the CryptoPunks contracts, that's going to be very much in the history of all time, which kind of piques my mind and says, hey, that's likely the subgraph doing that, because the smart contract probably wouldn't be doing that and computing that much all the time. This is likely the subgraph. And then what's the total value of all the contracts? This is the power of what a subgraph itself can do. There's a few new features on subgraphs that just came out called time series and aggregations. If you're interested in more features that involve compute, go ahead and search time series and aggregations. And that's going to really show you what subgraphs can do today. But right now, let's go ahead and send this query out for the contracts. We have the contracts. Boom. And let's just say the first 10, that's fine. We want the ID. And here we could see Jerry has done some compute on there. I'll make the screen a little bit bigger so we can see. If you hover your mouse over the actual field that may have a comment on it, it actually doesn't get bigger. This says total sales in ETH for punks. That means total amount ever traded since day one, which we found out was timestamp 14 something. And the total sales and the total supply. If you just hover your mouse, you'll see the comments. You don't have to go jump back and forth between the schema and here. It automatically populates right there, which is quite nice. So right now, we're in the first 100 sales and also the first pin. Let's actually get rid of sales here just to make this more clean. A lot of just clicking around, and we can see the compute is right there. So it's really cool. And then if we want to, we can send this query to the endpoint right there. So the last thing I want to do, if anyone here would like to do a homework query, they are absolutely welcome to do. It's a little bit more advanced. It's going to use some filtering and logical operators. That's there for that more advanced query. And then also, I do want to follow through and show how two different Messari subgraphs can be sent the same actual query. So we have a query designed right here. And these are both exchanges. We have Curve Finance and Sushi Swap to be able to send both of these at the same time to their endpoints. We could do this from within our decentralized application and get the total value locked between these two timestamps. And then we could also do that at Sushi Swap, which is pretty dang cool, being able to send both of these at the same time. Now you might ask yourself, cool, how could we do that? What's the technique to do that? I've got you covered with that. There is a actual part in this repo where we have what's called Graph Client, and you could send queries to multiple subgraphs at the same time. A great use case would be to use Graph Client with Messari. That's a pretty cool use case there. There's also a few different other techniques, but that's a relatively pre-made one for you there. And there's some video walkthrough on really how to use Graph Client. Let's go, and I want to highlight a few other things. If you're not going to use Graph Client, that's fine. This is a little cookbook about optimizing GraphQL queries. As you get more and more experience in subgraph development, optimizing those queries is going to be a big thing where you just really want to make sure that those queries are performant. If you have really huge queries, lots of nested queries, it does slow down the actual response and the speed of the return of that data. So making sure that's optimized, read this querying best practices. And then also, if you like using Python, this library is ready for you. This is a Subgrounds by Playgrounds. Playgrounds is the company, and their library is called Subgrounds. Go ahead and check that out. You can query subgraphs using the Python language. And then here we have DAppLooker. If you want to populate dashboards with no code, DAppLooker is there for you. So those are some things I want to highlight. A few takeaways. Always ask some great questions and then go to the graph network, and maybe those subgraphs are already there for you. So you can just go ahead and search around, see what's a good subgraph, and now you can understand how to send those queries and actually know what data you're getting back. Decentralized indexing, it's a really important part of the Web3 stack to make sure that Web3 is decentralized, and the graph is doing this on production websites all over the world every single day, 24/7. So that's really, really cool. There's 2,500 subgraphs plus ready for you and all of us to query today. So they're all ready for you and me to get building, all open data. Very cool. Graph Explorer, hop into Graph Explorer and see what data is available. Get to know about the Graph Explorer and also play in the playground. All right. So once again, this is the repo. I put it in chat, but if anyone's watching on YouTube, here it is. I'll put it in the docs, in the description below in the YouTube video. And also the Graph Builders newsletter. I write this every single month. So it's good to stay aware of what's going on in the graph ecosystem and what affects builders who are building applications, decentralized applications. So this is going to affect you. And that is everything. For those of you out there who are also building smart contracts and want to index those smart contracts and actually build up a custom subgraph, this is a really great place to start. This is a workshop and, a blog from Kevin Jones, who is also part of the Build Guild. And this is a great blog to really get your smart contract indexed well and easily in a local environment. It's very cool. So thank you very much. That is Querying the Graph Network. I will stick around here if there's any questions whatsoever. And yeah, let's see. Thank you guys for your time. How's everyone doing? Appreciate the applause.